Hey guys, this is a video for Spiral 1. This is kind of like a practice spiral. We've only got two sections on here. And the first section that we're asking you to take a look at is based on domain and range. The first thing I do is I give you a relation that's set up of 4 pairs of coordinates. And I'm going to ask you to identify the domain. Okay, we know that domain, we're looking for the x values here. Formally, what I can write is that the domain is each x value, so -1, 3, 1, and then 13. For the range, we know we're talking about the y values. And similarly, I can set that up and go -2. -2, I don't have to repeat any range values. 5, and my last one is 8. That's my range. Is relation R a function? We have a couple ways to explain this. The first is that each x value or input has a unique y value. This was the potato method. In other words, if I make a map, I don't know why I put -2 there, 3, +1, and 13, and -2, 5, 8. For each x value, I know exactly where I'm going for my y values. And even though 2 of the x values have the same y value, there's never a question. I can't say, what's the y value for x equals -1, and immediately you tell me it's 2. I can't have that go the other way. If I had 2 different y values for x equals -1, this would not be a function. This is a mapping way of saying something's a function. Each x value has only one y value. Graphically, we'd have like -1, -2, 3, -2, 1, 5, and 13, 8. This would definitely pass the vertical line test. There are no 2 points that are sitting on top of each other. Any other ways that you can think about this? I'm not really sure. If you have another way you like thinking about whether something's a function or not, let me know. And I'm happy to share that with other people. But this is a function, so yes. And you can use some mapping. You could say each x value has only one y value, or you could say that this passes the vertical line test. Here we're looking at the domain and range for a graph. This happens to be a parabola. And one thing that we need to get used to is making the assumption that if something continues off the edge of our paper, it's going to continue forever in that direction, which not a great thing to assume normally, but in terms of at least finding domain and range, it's going to be really useful for us. So this thing appears to be going on down and to the left, and it's going to keep going forever in both directions. That means it's going to -infinity on the left side, and down and to the right means that we're going to +infinity on the right side. This domain is -infinity to +infinity, or all real numbers, which you can use that funky R, if you'd like, as an option. For the range, well, it goes down forever, so it keeps going down. It's going to start at -infinity. Again, we use an open bracket or parentheses for that. And it goes all the way up, and it looks like it stops at a value of 1. And because that value exists, there's not a hole there or anything. I'm going to use a closed bracket for that. Is this relation a function? We know that for something to be a function, each input has to have one output. In terms of something visual, sometimes we do the vertical line test. We draw vertical lines, and as long as we don't hit any point along this thing twice, we're good. In fact, this one is a function. And one reason that I could give would be that it passes the vertical line test. So I'm going to say vert line test. Another reason that I could give is that each x value has one y value. And those would be 2 reasons why this is a function. For number 5, to write x is greater than 4 but less than or equal to 13 in interval notation, where I see my less than, I'm going to put a open parentheses. And when I see a less than or equal to, that's the upper bound. So I'm going to put a closed parentheses or bracket. And my starting value is 4. My ending value is 13. This means the interval from 4 to 13, with 4 being open and 13 being closed. Finding the domain of g of x is equal to the square root of 2x minus 5. I know for square root functions, the inside of the square root, what we call the radicand, has to be greater than or equal to 0. So I'm going to start out with that piece of information. So I'm going to make that inside 2x minus 5 is greater than or equal to 0. In solving this, I'm going to add 5 to both sides, divide by 2. I get x is greater than or equal to 5 over 2. That's one way to write that. If I want to use interval notation, I'm going to use a closed for greater than or equal. 5 halves is where we start. And since we don't stop, this is going to go into infinity. Whenever we have infinity, we have an open bracket symbol or parentheses. Here we're looking at some composition and some function operations. Our first one is asking us to find f of g of negative 2. I'm going to start from the inside out. And g of negative 2 means what's the value of g of x when x is negative 2. To do that, I'm going to plug in negative 2. So we've got negative 2 squared plus 5 times negative 2. Got to be careful with my order of operations here. I've got to apply my exponent before I use that negative out front. Negative 2 squared is going to be positive 4. And then negative in front would be negative 4. 5 times negative 2 is negative 10. We end up at negative 14 as our answer. Please be careful here. If you enter both of these things on your calculator, it's going to give you two very different answers. And the reason for that is that your calculator is not as smart as you. It can't sense your intentions. So when it sees negative 2 squared, it does the 2 squared first. It gets 4 and then applies the negative. When it sees parentheses negative 2 squared, it takes negative 2 times negative 2 and gets positive 4 like we did here. For number 8, fg of 3, that really means f of 3 multiplied by g of 3. So I can find those two things separately. F of 3 is going to be 3 squared minus 5, and that's going to be 9 minus 5 is 4. G of 3 is going to be negative 3 squared plus 5x, or negative 9 plus, 5x should be 5 times 3. Negative 9 plus 15 is going to be 6. 4 times 6 is 24. And if anybody noticed that I did not actually finish my first problem, I'm going to go back and finish number 7 now. So if g of negative 2 is negative 14, now I've got to find f of negative 14. All right, well, negative 14 squared minus 5. Negative 14 squared is going to be positive 196. Minus 5 is 191. That's a terrible 9. That's not much better. Looking at some function composition stuff, first I've got f of g of 0. So for this, I'm really going to find g of 0 first. In other words, what's the value of g of x when x is equal to 0? And if I look down at my table, g of x is 0 when x is equal to 0. So g of 0 is going to be 0. In other words, this is really finding f of 0. Okay, I'm going to do the same thing. So the value of f of x when x is 0 is going to be negative 2. We're going to repeat the same process for g of f of 4, but now we're going to start all the way on the inside and find the value of f when x is 4. So if f of x, we're looking in this row, when x is 4, that's going to be negative 4. So it's really g of f of g of, and then instead of f of 4, I'm going to write negative 4. So g of f of g of negative 4. Okay, I'm looking for the value of g That's here, when x is negative 4. Nice. So g of f of g of negative 4 is going to be positive 4. I'm sorry, just g of negative 4 is positive 4. I misspoke a little bit there, so instead of g of negative 4, I'm going to write 4. And we're ending up finding f of 4, which we already found. F of 4 was negative 4. So instead of f of 4, I'm going to write negative 4. And in finding g of negative 4, which we've also found already, we find out that g of negative 4 is just 4. The answer to this is 4.